Okay, we're moving on to our first lesson in Unit 4. Notice our title of the unit, Properties in Combining Like Terms with Rationals. Rationals. Rationals has been with Unit 2 and Unit 3 and the little decimal unit because a decimal is rational. And now it's following along with us in Unit 4. Here's the standard you're learning. You're applying understanding of order of operations and algebraic properties, that's what you're doing today, to generate equivalent numerical and algebraic expressions. And I'm just going to pause there because I just want to take this a little bit at a time. We are working towards the first bullet today, using properties to generate equivalent numerical and algebraic expressions today. And that's what we're going to work on. So, you need some vocabulary. Properties of real numbers is our main target today. And you need to know with properties, they generate equivalent statements. Equivalent are two statements that are the same. Bet you knew that already.
No.
Equivalent means same. And here are the properties. Maybe you remember them from the pre-test. We have commutative, associative, identity, zero, and the multiplication property of -1. That's more 8th grade level. Commutative is flipping. It's when you flip. A plus B equals B plus A.
I did get that.
That's the algebraic expression. Or 3 plus 5 equals 5 plus 3 is numerical. So commutative is flipping. Associative, how I think about this and how I always tell my 8th graders, think about the root word associate. Associate is like your group, your little group of friends. And when I think group of friends, I think that you guys are together in parentheses, in a little group. The parentheses represents like your little group of friends, okay? What associative property does is move the parentheses to different numbers or variables. Different things, different terms is the more accurate definition. So here, A plus B plus C is equivalent to A plus B plus C. It's equivalent, they are the same thing. B and C are hanging out, now A and B are hanging out. Numerical example. Is the following. And it only works for addition and multiplication. It doesn't work for subtraction, and it doesn't work for division. So 3 plus 5 plus 2 is equivalent to 3 plus 5 plus 2, because this is 3 plus 7, and this is 8 plus 2. 10 is 10. It doesn't matter. Doesn't matter. Only for addition and multiplication. Identity property, the value stays the same. That means 3 plus 0 is 3. Notice 3 stayed the same. That means 14 times 1 equals 14. The value stayed the same. So you have addition and multiplication. And then we have little zero property, which a lot of kids think that this first example is 0. Because they say, hey, I see a 0, it's 0 property. That is not true. 0 property turns the whole thing to 0. That would be 32 times 0 equals 0. That is the 0 property. It turns the whole thing to 0. And the next one is more of an 8th grade standard that I'm not going over right now. It just changes signs. Like, okay, I guess I'm going over it. Negative x equals 3. You can, because this isn't solved for in algebra world, you have to have x all by itself and it can't have a negative sticking to it. So you use the multiplication property of -1 to get rid of that negative. And it just changes the sign of everything. But you're not going to apply that. That is next year. Moving forward, let's apply our property knowledge. you are going to identify, look, aligned with your learning target, identify properties of real numbers. So x plus 0 equals x. What's that one?
Identity.
Identity, it stayed the same. So that would be identity property. It stayed the same. 3 plus parenthesis 5 plus x equals parenthesis 3 plus 5 plus x. Who is associating together? The 5 and x are associating together. And then, hey, guess what? The 3 and 5 are now associating. This is an associative property. Moving parenthesis. 10x times 0 equals 0. 0 property. Because it turned to 0. Remember, 0 property, the whole thing turns to 0. 5 plus 2x equals 2x plus 5. Commutative. I flipped the terms. So commutative. And you can use that front page today if you're still not, if your memory likes to just see the examples. Just go with it. y4 equals 4y. I flipped, right? I flipped the 4 and y. That is commutative. Okay? All right, so we defined properties. We identified properties. Now, we're going to apply properties to do mental math. Notice in our warm-up I said compatible numbers. Compatible numbers we can group around because of the commutative property. Because we can flip numbers around and it's going to be equivalent as long as it's addition and multiplication. So you want to group together facts you know. Okay. So I'm going to do the bottom one first because the top one's kind of weird with the decimal. So if I did 4 times 6 times 25, here's what some kids are going to do. They're going to say, okay, 24 times 25, and then they're thinking too hard. Because I bet you don't know this off the top of your head. So you need to do fast. Everything today is fast. So you want to know, what can I group together fast? 4 and 25 turns to what? 100 times 6, 600. So you are working with the commutative property to flip numbers around to find compatible numbers. Same strategy here, except the decimal is just a little weird. But if you notice the 7 and the 3, they're compatible because I can turn it where it ends in a 0. So 1.23 and 1.07 is 2.3. Plus 4.5 is what? 6.80. So when I look at compatible numbers, my goal is to have an ending 0. That's always my goal. When I group together numbers, I want to say, what can end in a 0 together? Because then you're working with tens. And tens are so easy to work with. That's my goal. Okay, moving to the next page. We are still applying properties. I'm either applying commutative or associative. Again, grouping together like terms and fast facts. All right, we want to simplify here. If I have 4 times 3x, you can reassociate 4 times 3 times x, which is 12x. Now you don't ever have to show the moving of parentheses. You can just apply it. If you have 4 times 3x, you would just go 4 times 3 is 12, put the x at the end. Let me just do one more example. 2 times 5x would be 2 times 5 is 10, put the x at the end. But what you're really doing is applying the associative property. You're regrouping numbers. Okay, here, 4 plus 7b plus 8. And this is definitely one that I see on a MCA test question. And I'm pretty sure you'll have one like this on your test. So right now I'm going to apply the associative property. 4 and 7b are hanging out. Now I'm going to regroup. This would be 4 plus 7b plus 8. Okay, this is going to turn really long. Now I can flip this. 4 plus 8 plus 7b. Commutative property. So this is associative that I regrouped. Commutative. And now I'm going to do associative again. 4 plus 8 plus 7b, which is 12 plus 7b. Cannot combine them because they're not like terms. I would never in the real life world do that much work. I just apply it. I would just say, okay, what can I combine? I can combine my 4 and my 8. It would be 12 plus 7b. That's in my real life math, would be the stop shop. But y is all of this. Okay, this is the y you can. This is just applying it. So 6 plus 4h plus 3. Right now I could combine my 6 and 3, right? Because they're alike. 9 plus 4h. That's that. But you know what? Remember I always said I like my variables first. Commutative property says I can put it first. 7b plus 12. Commutative property says I can put them first. That gets you prepped up for slope-intercept soon. Last one, and we did this. On unit, I forget which unit, 2 I think. Simplifying fraction expressions. What you want to do is cross out your common factors. If you can. And simplify the coefficients, which is numbers. So 12x over 4 would be, what's 12 over 4? Yep, 12 over 4 is 3, and you just put the x on the top. Or to the side. What you're really doing is dividing both of them by 3. What you have left on the top is 3x, and on the bottom you have 1. What do you notice I can cross out on the next one? X. So what do I have left on the top?
1.
1 over 3. What do you notice I can cross off on the last one?
Why?
The y. And then I could divide both of them by 2. And I have left 3x. That's it. A 1 on the denominator, but I erased it. I don't need to put that.